Hello, everybody. We're going to finish this. So if you remember, we had -1, 6. We're just going to finish plotting that left one up 6. Let's see, 1, 2, 3, 4, 5, 6. And then right 1, 0. And we're going to make a curve. Okay? All right. Let's look at a different one here. So we're going to just start by factoring this again. So step 1, by the way, this one is a little different. There's one like this in the homework. So I wanted to show you one where it turns out where it's not just two curves. So 2x minus 3, x plus 2. So factor the top, factor the bottom. Okay. And then we get to 2, and there are no holes because there are no factors to cross off. All right, so no holes, but we have 2 factors in the denominator. So I'm going to set both of them equal to 0. And solve that. So we end up with x equals -3 for one vertical asymptote and x equals +3 for another. So I'm going to go ahead and copy that in, put in the asymptotes, okay? Then we get to horizontal, and here the degree of the numerator is the same as the denominator. So that means we take the ratio of the lead coefficients, which is 2/1. So the horizontal asymptote, and that means there's no slant, is 2/1, which is just y equals 2. Okay, so this is where it gets a little funky. It's, because we have 2 vertical asymptotes, we've got an asymptote at -3, and we have an asymptote at +3. So I'm going to do my usual 1 below, 1 above, okay, and plug those in. So when I plug in to the original, we always, except for the hole, we go back and we plug it into the original. When I plug in the original, -4, I get 3.1. So that's left 4 up a little bit over 3. So we've got a curve here. And when I plug in +4, I get about 7.2 or so. So it's something like here. And I'm going to draw that curve. So now we don't have curves that are kitty corner like we do when we have one vertical asymptote. We have 2 curves. In this case, they're both above. And we're going to end up with a parabola in between. So if I get -2, 0, and 2, and again, go back and plug them into the original equation. When I plug in -2, I get 0 for y. When I plug in 0, I get 2/3, which is about 0.67. And when I plug in 2, I get 7.2. So we'll go and we'll plot those points. Yeah. Oh, sorry, that last one was not 7.2. I was looking at the wrong one. Okay, that is actually about -0.8. It's like, that doesn't make any sense. So right to something like that. Okay. So yeah, they should all be in the same little blocked off area there. And it's a parabola. All right. So that was kind of an odd one. We're going to go back and do another one that's a little bit more normal again. So just some more examples. Step 1, factor. Step 2, look for holes. Well, x plus 6 crosses off. So that means that x is negative 6. And y, if we plug that back into what's left, so this is what's left. It's 3 over blank plus 2. So if I replace that with negative 6, I get 3 over negative 4. So negative 3/4. So I'm going to go left 1, 2, 3, 4, 5, 6, negative 3/4. So I'm just going to put the hole there so I remember to put it there. Vertical asymptote, set x plus 2 equal to 0. And when I solve that, I get negative 2. So we'll add that. Something's awfully funny. I don't know if you can hear my daughter giggling in the background there. Probably TikTok again. Okay, so for 4, we're asking ourselves if it's vertical or I'm sorry, if it's a horizontal or a slant. Well, for the slant, the degree of the numerator has to be higher. In this case, the degree of the numerator is higher. And in that case, we have y equals 0 because the degree of denominator is higher. Okay, so this is just y equals 0. But then we just do the same thing again. So for step 5, because my vertical is negative 2, I'm going to go down 1 from there, up 1 from there. So when I plug in negative 3, I get negative 3. When I plug in negative 1, I get positive 3. So left 3, down 3. And left 1, up 3. Okay. All right. Last one, and the only reason I want to do this one is because long division comes up. So one more example. This one actually ends up being off the graph. But if I try to factor this one, I can't factor the top. I try, I can't factor. And because I can't factor, there are no holes because there's nothing I can cross off top to bottom. I take this, I set it equal to 0. I get a vertical of 4. Seems like everything's going so smoothly here. But then when I look at horizontal or slant, it is a slant because the degree of the numerator is higher than the denominator. So that means I'm going to do some long division. 4x squared minus 7x plus 2. And when I do long division, I concentrate on the first terms here and ask myself, what do I multiply x by to give us 4x squared? 4x. So 4x times x is 4x squared. 4x times negative 4 is negative 16. So if I subtract this, that's the same as adding the opposite. So the 4's cross off, and we end up with negative 7 plus 16, which is 9. Drag down the plus 2, and we start again. What do I multiply x by to give me 9x? And that's positive 9. You know, now I could multiply this all out and find out what the remainder is. I don't really care. I just want to know what is my slope, it's 4, and what is my y-intercept. Okay, so this is where the problem lies, at least if I keep my, my units as going up by 1s, which I did. But the y-intercept there, that's not very straight. Okay, I can do a better job than that. But the y-intercept is 4. I'm sorry, the y-intercept is 9. And the slope is 4. So down 1, 2, 3, 4 to the left 1. right? And I go 1, 2, 3, 4, and to the left 1, 1, 2, 3, 4, and to the left 1. Boy, it'd help if I didn't get all these other little dots in here. Okay, but then we would just connect that. And again, you can see the asymptotes go way off the graph. You know, it ends up being something like this, where it, if we graphed it, we would end up with something down here. Here, I'll do that in black. Come on here. Down here and up here, okay? Yeah, so like if we went to the left of 4 and the right of 4, if I were to plug in 5, I would get something like 67. So again, it's way up here. You know, it's way up here somewhere. And if I were to plot 3, I get negative 17. So again, you know, way down here somewhere. All right. Yeah, so we can't even see the one up to the right. Again, I mostly wanted to do that so you got another example where there was long division. Okay, so there's several examples to go by. So try some for yourself in the homework. Have a great rest of the day.